Okay, question 1, does anybody need me to go through the answer? No? Skip. Question 2, anybody needs me to go through? Don't be shy. If you need help, you need to stand up. You need to let me know. Don't need to stand up, you need to let me know. Okay? So, this is used to measure the external diameter of a tube. What is the diameter of the tube? Basically, read the reading from the vernier calipers. Reading from the vernier calipers is easy. All you need to do is to look at a 0 at a vernier scale. Look up. Where is the marking? Just before the 0. And this is the 1. Right? Just before the 0 on the vernier scale. What is this value? 4.6. Then next we look for where they coincide. Where do they coincide? 0, 1, 2, 3, 4, 5. Where is it? Which one? 2. They coincide over here. So 4.62. That's the answer. Alright? 3. Does anybody need help? Okay. Not a derived quantity. So we are looking for base quantities. Which is a base quantity? Does this help you answer? Which one is a base? How many base quantities do we know? How many? 7. We know 7 of them. Remember? Ask you to memorize them. And time is a base quantity. Everything else is derived. Why are they derived? Area is by length times length. Your speed will be your distance over time. Volume will be your length times length times length. A clue will be from the units. If you look at the units for area, we've got square meters. For speed, we have meters per second. For time, we've got seconds. For volume, we've got cubic meters. Now, which one of these looks like a base quantity to you? Time, seconds. It is not made up of any other thing. It is just by itself, seconds. Everything else, A, B, and D, they are made up of different parts. Okay, that is why we call them derived. Question 4. Which one is not a base quantity? And this is like an opposite question to the previous one. Who needs help for this? Okay, which one is not a base? Means we are looking for a derived quantity. So which one is derived? Weight. Everything else is part of the 7. Question 5. Who needs help for this? Okay. To measure the diameter of a rod. Okay, a rod looks like this. How do we measure the diameter of a rod with a meter ruler? Is it possible? Is it possible? I illustrated with you, right, to measure the diameter of a beaker last lesson. Then we had a problem. We didn't know where the center was. So meter rulers are never good for measuring diameters unless you know where the center is. Okay, so this is out. Diameter of a basketball. Now vernier calipers, they have jaws. They got mouth, they can open and close, right? So we say it is useful for us to measure the diameter of a beaker, for example. But basketball is so big, vernier caliper so small. So it's not a good idea as well. Inner diameter of a mug. The vernier calipers has jaws. It can be used to measure external diameter. It can be used to measure inner diameters as well. Okay, so this is the answer. C. And obviously you can't use a ruler to measure the thickness of a pen. Next, question 6. Anybody needs help? Okay. Understand the question first. Shows the scale of the vernier calipers when it's fully closed. This is the one where it is fully closed. What do you think they're trying to get you to see from here? I heard the answer already. What are they trying to get you to see from here? 0 error. You close it fully, what should you see? 0 and 0, isn't it? Do we see 0 and 0 together? Do we? No, we don't. Where is the vernier scale? To the left or to the right? It is to the right. So we write out 0 error equals to, is it a positive or negative one? Positive or negative 0 error? Positive, yes. See, you know it. So positive how much? All we need to do now is to read it. read it the same way as we read the vernier calipers for all our measurements. Find the 0 over here. Look up. And we see that, hey, this is the value that is just before the 0 on the vernier scale. What is this value? 0. Specifically, it is 0.0. 0.0 what? So you look at where they coincide. Where do they coincide? 3. So 0 error is 0.03 cm. That is too much by 0.03 cm. Now we look at the actual measurement. Okay, we are using the same vernier calipers, the one that has a 0 error of 0.03, to measure the length of a box. Okay, so this is our observed reading. This is what we see. Okay? Look at the 0 again on the vernier scale. Look up just before the 0. What is this value? 11.1. 11.1. And what is where do they coincide? 8. Yes, over here. 8. So this is 11.18 cm. Now that I have the observed and the 0 error, how do I find the actual length? Minus. We always minus the error. Today we are giving you positive 0 error, so it's easy. 11.18, so this is the actual, equals to 11.18 minus 0.03. And that gives me 11.15 cm. Answer B. Most likely, we will test this for you. But I do not know, I didn't see the paper. But if I'm the setter, I will set this. Okay, question 7. This person measured something using a meter rule, and he sees that this is 2.13 cm. Okay, so what kind of error do you think he committed? Yeah, parallax error. So C. Next. Question 8, this is a pendulum. From B to C, it took 0.2 seconds. Does anybody need me to go through this question? If yes, please raise your hand. Okay, so from B to C, it took 0.2 seconds, right? What is the period? What exactly is the period? No, it is a time taken for one oscillation. Time taken. No, what is one complete oscillation then? If you look at the fan, can you tell me when is one complete oscillation? It must go back to its starting point. So if it started from B, then it moved to C, where is it going to go next? It goes back to B. Is it considered one full cycle already? Did it complete one full cycle? No. Where will it go next? You go to A. Then after that, is it a full cycle already? Not yet, it has to go back to B. Now when it goes back to B, is it a full cycle already? Yes, it is. And what is the total time taken? If this is B to C, 0.2 seconds, C to B is also 0.2. B to A, still 0.2. A to B, still 0.2. What is the total? 0.8. Easy? Easy? No, the answer is 0.8. D. It's just multiply by 4 or add them all up. Okay? Now, this part, 9. I gave you time to memorize. What is micro? What does micro mean? 10 to the power of? No, not negative 10. 10 to the power of negative 6. So I want to convert from microseconds to seconds. So this is my step. I always do the same thing. I copy down the number 1000. Now micro, I told you to memorize that it is 10 to the power of negative 6. And so this part over here, micro, is this part. Then I copy down the seconds. Okay, how do we read this? This is 1000 microseconds. Did I change the question? Is it still 1000 microseconds? Yes, it is. If you like, you can use your calculator to help you for this. 1000 times 10 to the power of negative 6. Okay? Alternatively, you may remember 10 to the power of negative 6, or rather micro as 1 over 1, 2, 3, 1, 2, 3. 1 million, right? Yeah, 10 to the power negative 6. Alternatively, you may write 1 over 1 million. That is the same for micro. You may do this with your calculator. Can you tell me what's the answer then? Primary school maths, you should be able to do this, right? 1,000 divided by 1 million. What do you get? This is your calculator if you need help. How much? 0.001 seconds. Alright? So this is the answer. Any questions? Part B, do you need me to go through? Can we leave it as a fraction? So you left it as 1 over 1,000? You can, but in physics we usually leave it as decimal. So I would like you to use green color, change to a fraction. Change to a decimal. Make this a habit for physics. Final answer will always be in decimal. Okay? Mathematically not wrong. Your math teacher will say, yeah, correct. Your physics teacher say change it to decimal. Okay? Now, part B, who needs me to go through? Anybody? Okay. This W over here refers to watt. It is a unit for power. Okay? Just note that it is a unit. My main point over here is, what does this G stand for? Giga, okay? What does this M stand for? Mega, okay. Let us write them all down. So, my approach to the same. I will copy down the number 23. What does giga mean? 10 to the power of 9. So, this is 10 to the power of 9 with a watt. So, we read this as 23 gigawatt. If you are not familiar with 10 to the power of 9, you want to write down all the zeros. Yeah, sure, go ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9 watt. So now this becomes gigawatt. Okay? And on the other side, we've got megawatt. What does a megawatt mean? What does mega mean? Well, mega is 1 million, right? 10 to the power of 6, which is 10 with 6, which is a 1 with 6 0, 2, 3, 4, 5, 6. Right? So megawatt simply means 10 to the power of 6 watt, which is 1 million watt. Okay? So 23 with 9 zeros watt equals to how many with 6 zeros watt? What do you think is the answer over here? 23 with how many zeros? How many? 3 zeros. Right? Yeah, we simply divide by how many zeros? Divide by 6 zeros. So this is a pencil, you can cancel. 3, 4, 5, 6. 4, 5, 6. Left is 23,000. Can? This is how you convert with your kilograms to grams anyway, right? Okay, next, question 9 again. State the precision. This you were told to memorize. What if you forget? I can't remember what is my precision of meter rule. How? Check your own ruler. Yes, you have a ruler, right? Take out your ruler. What is the smallest reading that you can possibly have? 0.1 cm. That's it. Everybody should have a ruler in their pencil case. Now, vernier calipers, is it more powerful than the ruler? Yeah, it is. So do we expect the precision to be higher? So what will the precision be? See, if you know the precision of a ruler, you know the precision of a vernier caliper straight away. Now, conversion. Part A. Do you need me to go through? No, primary school maths. Part B. Need me to go through or not? Yes, again. Same type of the question, right? Okay. So here what is the first step that I want to do? Write down 500,000. Yes, thank you. 500,000. What do I write down next? Times. What does this mean again? Micro. So that refers to 10 to the power of negative 6. Or if you prefer, it is 1 over 1 million. 2, 3, 1, 2, 3. So this is my micro. What else is missing? Seconds. Okay, so here we have, this is simply 500,000. This is micro, and this is seconds. I am just rewriting it. 500,000 microseconds. Okay, and our final answer, it has to be in seconds, right? which is found here, isn't it? Well, if the two yellow parts are the same, they are all seconds. What do you think goes into the blank? The blank must be this. So what is this value according to your calculator? Are you sure? 0.5. That's the answer. Can? Let's try the next one. 1 million milligrams. What is a milli? What is a milli over here? This one. What does it mean? 1 over 1,000. Yes, this is 1 over 1,000. So I can rewrite my 1 million milligrams as 1 million times 1 over 1,000, which is the same as divided by 1,000 with a grams. Okay, let me highlight which are the equivalent parts to you. So the yellow one will be the number. I've got a green one, which is my milli, and then I've got in purple the grams. Okay, they all correspond to each other. The yellow is the same as yellow, green is the same as green, purple is the same as purple. Alright? So now I am trying to convert it to grams. What do you think my value will be? 1,000. How much? What is the unit? 1,000 what? If I convert it, 1,000 grams, right? Now from here on, I'm sure you can tell me that this is how many kilograms? 1 kilogram. Okay? Okay, next. This is a pendulum experiment. Can visualize what is happening over here? Is your imagination? Can, right? Basically, it's just a weight. In this case, we call it a bob. On a line, on a string. And it is swinging. The line has a length. It is called L. So in our table, what do you think all these represents? Yeah, this must be the length, right? He is changing the length to see how the time taken for 20 complete swings changes. So most of you were able to do this to find the average time. Now, just to check on your understanding, what does this 40.37 mean to you? What does it represent? Time taken for 20 oscillations. In the diagram, the instructions, they said measure time taken for 20 complete swings. In our table, we say time taken for 20 complete swings. So for the length of 100 cm, how many times did he do it? How many times did he do the experiment? 2 times. And he got 40.37 and 40.14. So find the average. 40.37 plus 40.14. And we divide this by 2 to get the answer. Into 2 dp. I specifically asked you to leave it in 2 dp, right? Okay, so you do the same. Find the average for all of them. Average, put it over here. Average, put it over here. So on and so forth. Now that we have the average time, how do we find the period? This average is still for 20 oscillations. So if I want a period which is for 1, what should I do? Divide by 20. So from here to here, divide by 20. And you get the answer, again in 2 dp. You can try it yourself. These are the values. Okay, so now you get to copy down the correct answers for the correct values. Then, after the lesson, go use your calculator to check. Is it really correct? Did I make a mistake? Because now you all know how to do it, right? And then you need to practice your rounding off. Okay. Finally, last few parts. Explain how the period changes with the length of a pendulum. So you can choose to copy down any one of these. They all mean the same thing. Okay? If I were you, I will copy this down. Because it's the shortest. As the length increases, the period increases. That must therefore mean as the length decreases, the period decreases. Finished? We need more time? Raise a non-writing hand. Yeah, make it fast, make it fast. I only have about 2 minutes left. Okay, does the period of the pendulum depend on the mass of the bob? No, it doesn't. I told you that it only depends on the length of the string. Right? As shown in the experiment over here. We see that as the length changes, the period changes. Look, when the length was 100, the period was 2. As the length decreased, as it got shorter and shorter, the period got smaller and smaller. Okay? So, only the length will determine the period. The mass of the bob does not. You can try it out yourself. Same length, different mass. Time it. It will be the same. So, that gives you one easy mark. Part D. How will you modify the experiment to investigate whether you are right or wrong? So you may copy this down. Basically, we just repeat the same experiment. But this time, we use bobs of different mass. Okay, you can use 10 grams, 50 grams, so on and so forth, and calculate the period for each bob. I want you to include the words in red. While keeping length of string constant.